Today we're going to be learning system of linear equations word problems. While these are only worth 7 points on the average SAT, they are tested more heavily on some, and the underlying concepts behind them are really important and in a lot of other concepts, so this one is definitely worth knowing. So our approach to these problems is going to be to identify systems of linear equations word problems, to read the problem, we're going to create a formula to solve these questions, and then we're going to solve a practice question. So how are we going to identify these? Well, they'll look like a brick of text with two linear equations described in that text. And it's your job to recognize those equations. And you're often asked to find a solution to these equations. And as we'll go over when we look at the Desmos portion, a solution will also just mean an intersection point. Now, sometimes these questions will try to get tricky on you, and they'll ask you like x plus y, or what is x plus 3. And so make sure you're reading the question carefully and fully understanding what they're actually asking for. Don't just assume it's x or y or xy. So here's the 3 steps in our formula for systems of linear equations word problems. We're going to create the 2 formulas from our text. We're going to write down what we're looking for. And then we're going to use one of our methods, so substitution, elimination, and Desmos. One of those, or maybe a combination of 2, to find our intersection point. And that is if you have one. Sometimes you'll have parallel lines that look like this, and these are going to be lines with the same slope but different y-intercepts, and those are never going to intersect, so they'll have no solution. So let's look at an example of this question type. The question reads, a theater sold 175 tickets for a play, with adult tickets costing $15 and child tickets costing $10. The total revenue from ticket sales was $2,500. And the question is asking us how many adult tickets and how many child tickets were sold. So let's look at step number 1. We're going to create our 2 formulas from this piece of text. So I'm going to look and see 175 tickets, and I'm going to see that we're selling adult tickets and child tickets. So between the combination of child and adult, we sold 175 total tickets. Now, in our second equation, I'm seeing that these adult tickets right here are $15. So 15 times the number of adult tickets we sold, plus we have child tickets, and those are $10. So 10 times the number of child tickets we sold. And these two have to equal the total revenue, which it tells us is $2,500. Okay, so now we're done with step number 1. We created our 2 formulas, and now let's move on to step number 2, and we're going to write down what we're finding. Well, we're finding how many adult tickets and how many child tickets we are sold. So this one's not too confusing, but we're looking for number of adult tickets and number of child tickets. Okay, so now let's add these together and use our equation to find our answer. So I'm going to use substitution here, and I'm going to isolate c. So in our first equation, c plus a, I'm going to rearrange it by subtracting by a on both sides to get c equals 175 minus a. So just a simple rearrangement of this formula. And then I'm going to now plug in this c we found into our second formula. So 10 times, it was c, but now it's 175 minus a plus 15a equals 2,500. Okay, now let's add out a little bit. Okay, now I'm going to subtract 1750 from both sides, and I'm going to combine these like terms here to get 5a equals 750. And then I'm going to find our answer of A equals 150 by dividing by 5 on both sides. So A of 150, I can actually just see B is correct here, but let's find C anyway for children tickets, just in case we didn't know from just that. So C equals 175 minus A, and we found A is 150. And so this confirms A of 150 and C of 25. And B is our answer, as you can see. Now, this is a concept that you definitely want to use Desmos for. While you're going to have to find those equations within the text, once you find them, you can plug it into Desmos and save yourself time. Okay, so here we're in Desmos, and as you can see, I plugged in our two equations. Now, an important note here is that in Desmos, you can't use A or C because Desmos is going to think that those are constants instead of variables, and so only use X and Y in Desmos. So I just transferred our A and C to X and Y, and I plugged in our two equations. Now you might be wondering, you don't see anything on the graph here, did I mess it up? Where's the graph that I just plugged in? Well, it's important to note that you have to zoom out sometimes to be able to see your graphs, especially if you're working with big numbers like 2,500. So let's zoom out a little bit, and we can start to see our lines. So let's go up to where it looks like they intersect and zoom in. And if I point in the area where it looks like they intersect, I'm going to get this point 25, 150. So 25 for X, 150 for Y, and 25 is going to be our correct answer for child, and 150 is right for adult. So definitely use Desmos on these problems when you can. It'll save you time doing all that long work, or if you already did the work, it's going to help you make sure that the answer that you got is correct. So good luck.